Welcome back to .NET Rocks. This is Carl Franklin.
And I'm Richard Campbell.
And we're here in Sydney at NDC Sydney. You know, the thing that really occurred to me last night as we're socializing with all these people is how many smart people are in the same room. Right? You know? And you find yourself like seriously outclassed by people who
Some
have
wildly smart people
who have like no ego about it either. Yeah. They're just like, oh yeah, I just kind of, you know,
do this thing.
Yeah.
You
know, and the people that we talked to yesterday and the day before is just so many great people walking around here.
Yeah,
it's
extraordinary. And I think the NDC folks always have a knack for picking the nicest smart people I've ever met. Over and over and over again.
Yeah.
Maybe not Daniel. We'll find out.
We'll find out about Dan. Yeah.
Get my clothes out.
That's right.
Here he comes.
Yeah. Dan Chambers is here. We're going to be talking to him soon. But first, we have this little matter of better know a framework.
Awesome. All right, buddy, what do you got?
So this being show 1590, if you go to 1590.pwop.me, you'll find this GitHub repo called You Don't Need Moment.js. It's a list of datefns or native functions which you can use to replace Moment.js plus ESLint plugins, which can be 70K or greater.
Wow.
Yeah, so Moment.js is a fantastic time and date library with a lot of great features and utilities, but if you're working on a performance-sensitive web application, it might cause a huge performance overhead because of its complex APIs and large bundle size. So there's a few particular problems with Moment.js that they call out on the repo. One, it's highly based on object-oriented APIs, which makes it fail to work with tree shaking. So that leads to a huge bundle size and performance issues. And number two, it's mutable because it's OOP APIs and non-pure functions, which causes bugs.
Right.
So if you're not using time zone, but only a few simple functions for Moment.js, it might bloat your app, and so therefore it's considered overkill. Day.js is a smaller core size, but it has very similar APIs, so it makes it easier to migrate. And datefns is another one that enables tree shaking and other benefits, so it plays well with others. So it's kind of a cool list of things, the reasons that you don't need Moment.js.
It's a really interesting project, right?
Yeah, it is.
It's sort of a way to sort of take people further down that path. That's cool. Fine,
yeah,
man.
It is cool. Chris Love's going to love this. He's probably already using it.
Yeah, I'm sure he is. It's like, oh, I'm so glad you finally found out about that.
Yeah, right. So who's talking to us?
No, we're going to talk a little bit of F# today. I grabbed a comment off of show 1473, and that's the show we did with Scott Walsichin at NDC Oslo. 2 years ago, September 2017 is when we published it, but I think we probably recorded it in like June.
Yeah.
You know, sometimes when we're at NDC, we'll knock out like a dozen shows.
Yeah, like this trip.
Yeah,
we did 8.
Yeah, we're doing 8. There's nothing wrong with that. It's fun to get, you know, to work and get a bunch of these things done. Great conversation. I think we really had a lot of fun. Because that was about C# developers using F# techniques, right? And what it sort of takes to move to F# and what it has going for it. Got some great comments on this show. One of them is from Sammy, who says, I love this free-flowing conversation, but I was dying to find out, how did Scott land on F# of all the functional programming languages out there, giving his varied and not necessarily Microsoft background? Sadly, that question never got asked, which is interesting. Why didn't we ask that question? Also, I would love to get some perspective on why Scala is a kitchen sink language and F# is not. I thought both of these were hybrid functional languages. And conveniently, Scott did respond to him. He said, thanks so much for listening. I started with F# because I was doing a lot of C# at the time, and it was right under my nose in Studio 2010, which is, you know, that's a significant feature. It's like, you don't have to go out and get anything. It's already in the box. It compiles the CLR. You think about how much you already know if you're comfortable with Studio in terms of experimenting with functional languages. And regarding Scala being a kitchen sink language, this is a comment that Scott made on the show. It means that there's a lot of different ways of doing something, and the design philosophy seems to have been, let's add this feature if it might be useful for somebody somewhere, right? So sort of that less opinionated mindset versus the more opinionated mindset. Other languages like Perl and C++ also give this impression, definitely. F# tends to be much more conservative about adding language features, and we know this from talking to Don Syme. Like, they really debate what to add to that language. They're very, very careful. And I think it's a modern way to go. You know, once upon a time, it was just about adoption, throw in anything that anybody might want.
Yeah.
But these days, the fact that you can build in open source and that you can have an interaction with your impassioned community, I think we're setting the bar much higher for how we make features. And I think it's a shift in our culture as language creators that's different from ever before. That's one of the reasons I grabbed this comment. Just that's a really interesting thought that it's different now. Our world is different now, whether we know it or not. So, Sammy, thank you so much for your comment. A copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or via any of our social media, because we publish every show to Facebook and Google+. And if you comment there and we read it on the show, we'll send you a copy of Music to Code By.
And definitely follow us on Twitter. He's at Rich Campbell. I'm at Carl Franklin. Send us a tweet, but only pure tweets. We're conscious of...
What's a pure tweet?
Yeah.
All right.
Okay. Well, let me introduce our guest today, Daniel Chambers. He has passion for functional programming and quality software. During the day, you can find him writing Haskell and for the .NET program with F# and C#. He works as a senior consultant for Redify. Welcome to .NET Rocks, Daniel.
Thank you very much.
You're not with Redify anymore.
No, just changed recently. Wow. Yeah.
Just at this conference?
No, so I'm 3 weeks into the new job.
So I scheduled you for this a month and a half ago.
Yeah.
And in that time, he's changed roles.
Yeah.
Wow. Well, they need to update the bio on your on the website.
Yeah,
for
I haven't
NDC.
changed it on NDC Sydney yet.
Okay.
I figured.
So what's the new job?
So the new job is with a company called Liberty Financial.
Cool.
Yeah, they're a company that basically do loans. So they're a lender, and they're looking to head down the functional path.
Neat.
Which is why
that would be my question.
Board.
It's did they want you for your functional skills?
Yes, they did.
That's really cool.
Which is nice.
That's really interesting, I think. Yeah.
Yeah, so what are you talking about here?
Let
me guess.
Yeah, my talk that I just came off of and finished was about Haskell and sort of trying to give people an idea of why they might consider Haskell as a good functional programming language. So what are the features that Haskell provides to you as the developer that would make you go, this can help me write better quality software.
And is there a managed version of Haskell?
Is there a Haskell.net?
No, there isn't a Haskell.net. Haskell has its own runtime.
Okay.
So when it compiles down to native code. In fact, most things are statically linked into the binary. So you can just pick up the binary and run it without a runtime.
It's open source, if I remember correctly.
Yes, yes, it is. Haskell has a long history, sort of coming from the research community.
Okay.
So it's a language that's evolved over a long period, so there are lots of features to it, and if you look at the way the language is built, you can kind of see that.
Okay, for better or worse.
For better or for worse, yes.
We've made the pitch many times to C# developers why you should learn functional programming, and F# should probably be your intro to that. Somebody who's done a little F# and now you have to make another pitch. Hey, let's get out of the framework altogether.
Yep.
And what are those features that make that enticing?
Into Haskell from F#?
Yeah.
So I think the biggest thing about Haskell that's different to F# and that makes it compelling for me is its strictness in terms of a language. So Haskell enforces purity and immutability, which means that unlike in a language like F# where I can write pure functions and I have immutable data types, I can also write mutable functions and use mutable types.
Right.
In Haskell, because it's not a hybrid language with something like .NET, and it doesn't have to interoperate with mutable code, it just doesn't have those features at all.
Right. So, objects.
No objects. No. Well, there's state. You maintain state. You have to in a program, but there's no mutable state. So everything is immutable, which means that when I look at code, it makes it easier for me to understand what it does and trust what it does and what it can't do. Almost more importantly, what it can't do, which actually makes, in my opinion, maintaining and reasoning about a program much easier.
Right.
Because there isn't any black magic.
Yep.
And there can be no like dirty stuff under the covers. So you lift up the edge of the rug and then find out everything's being swept underneath. It's much more difficult to do that in Haskell. The language pushes you away from it.
I'm reminded of Mark Seaman talking about how constraints liberate.
Yes.
Sure. I mean, that's really there's a perfect example of that.
Yeah, absolutely. And Haskell is a very constrained language. It puts a lot of constraints on you.
So what's it really great at? Why would you want to use it? I get the sense that you're going to enjoy the language because you're living in a very clear box.
Yep.
But when you're the architect and looking at a set of problems, what are the ones you go, we should put Haskell on that problem?
Personally, I think it's problems which are complex, with lots of...
Mathematically?
perhaps mathematically, or just in terms of just business rules and the way you compose things together, or whether it's flipping data around. So I think data processing it's very good at.
Great.
Those sorts of problems where expressing it, and you need the ability to be able to express something clearly without letting the plumbing of how this thing's tied together get in the way is important for your understanding. So because Haskell is a functional language, it makes it easier to write DSLs for things.
Oh, interesting.
So you can write a DSL for your particular problem, and that makes it easier to express. So like an example would be a parsing. If you want to do parsing, there are libraries that are effectively a DSL for parsing that mean that you can write parsing logic in a way that reads more easily. Like, yes,
very terse, clear.
Correct.
Like I know what I'm trying to parse here.
Exactly. You don't. The parser and the library sort of takes care of the underlying plumbing of how this thing is wired up and how it consumes tokens off a stream and all this sort of stuff. But what you actually see is, well, I want a word and then I want, a number and, I want to throw away that number, or I want some white space now and chuck that away. And so you can compose together this language. It's like a sub-language in Haskell, if you like. That's why it's the DSL. And then you can more easily see what you're trying to actually achieve there as opposed to all the plumbing.
Oh, I really appreciate that. That's good. It's some cool thinking. The challenge, of course, is I'm thinking it's two sets of problems. One is I got to figure out what my dev environment is for Haskell. And then I also have to figure out how to interoperate with it with the other apps. So can you sort of talk me through, let's worry about the dev environment a second. What's the normal interaction model so that Haskell lives in a larger application landscape?
You mean in terms of how would you integrate it with other applications?
I'm going to presume I'm not going to build a lot of GUI with Haskell.
No, probably not.
Right. So here I am living in happy.NET land, maybe a web page, and I've built the UI, and then they're going to make a call. Now I've got to be able to package up my data and ship it to a Haskell execution path.
Sounds like an interop problem. Isn't it?
Yeah. Look, these days I'd probably do it as a web service. So Haskell has really good libraries for writing web services. So I'd probably just make a Haskell web service. Make maybe whatever that thing you want to do in Haskell. Let's say you cut off a bounded context out of your problem, and that becomes a new microservice. Maybe you'd write that in Haskell, expose its functionality as a web service, and then call it from your C# front end or something.
Blanca like JSON with just the parameter set.
Exactly.
Off it goes.
Yeah, you can maybe write a SPA in, React or something and then call your Haskell backend.
Well, and what I love about that is my front-end developers have no idea and don't care.
Yes.
Don't care.
Right. Like it doesn't matter. In fact, then one argument you could make is you have an implementation in C# or F# and you're not happy with it in some respect. And well, let's try redoing it in Haskell and see what the differences are like.
Does Azure have native support for Haskell?
It has, I wouldn't say native support. Yeah, with containers. I think what Azure has now is native support for processes. So it doesn't really matter what you write, particularly with technologies like containers. It doesn't really matter what you write your executable in. So long as you can run the thing as a process and expose a port, you can run that thing, which is really nice. And I think that's the direction like containers and, things like Kubernetes and AKS are taking us towards, which I think is very valuable because I think it lets people experiment with different technologies and play with things in a way that previously might have been a lot harder.
It's certainly meant for the services model. Then you have some elasticity of how you scale it, and you're only doing the things you want, and you would not maintain state within the container anyway. You'd be passing in values, it'd be doing its thing, and it'd be passing by results and then dying.
Yes, correct. Or you'd be persisting it outside in some other service.
No, I appreciate that. That's a good model.
So, in your financial gig now, you're probably doing a lot of this with Haskell for all of these algorithms and trying to find gold in needles in haystacks. And
I'd like to say we were writing Haskell at Liberty, but they're just starting on their functional path. And so before I got there, their engineering guild got together and decided the long-term direction, maybe medium-term, long-term direction they want to go is F# because they are originally a .NET shop. So they've got a whole bunch of .NET developers who are experienced in C#.
But you definitely must have a lot of ideas about what you're going to do there.
Yes, yeah, definitely.
Yeah. But it's early days. You probably just get your feet under you right now.
Yeah, exactly. So I feel like I think F# a decent choice for them because of their history in .NET. But if they're anything like me, they'll probably, once they get some experience in F#, they'll start looking outside of it. And then maybe at that point, they'll have the confidence to take the step towards Haskell. Because you can understand from a company's point of view, the risk of adopting something as different as Haskell is.
Sure.
Yeah.
So I think for them, quite reasonably, F# is almost like a nice half step.
It's a super safe choice.
Yeah.
You know it's going to work. It's literally compiling to IL, and so it's going to work in all of the same distribution pipelines.
Yeah.
It's going to have the same debugging behavior. There's so many things that are just taken off the table because you're living in studio.
Yeah.
So it is an easy thing. But tell me what happened to you that got you thinking outside of F#.
Okay. So when I was working for Redify, one of our clients was Seek, and I went to Seek to help them write F#. So they had a team that was writing something in F#.
Is this SEEK, Seek, or
Yes.
SIKH?
Yeah, SEEK.
Okay.
They're
Okay.
they're a very popular like jobs board for
All right.
Australia. So if you want to hire someone, you post an ad on Seek,
Right.
and then people apply. So I was there helping a team there write F#. So they were already writing F# and they wanted an F# developer. Now, Seek went down the AWS path rather than the Azure path.
Sure.
And they were originally a .NET shop as well, but over time they've sort of moved away from .NET into other languages.
Mm-hmm.
And I think maybe a part of that was influenced by the fact that they were on AWS rather than on Azure, because on AWS, in my experience, deploying .NET is nowhere near as easy as it is on Azure. Microsoft make it very easy for you, whereas on AWS, it's perhaps less easy. So the deployment pipeline when I got there for deploying F# was basically spin up a VM, because AWS is really good at VMs, and then deploy into this Windows box and run it. And that deployment pipeline was very slow because you've got to spin up a new VM, booting up Windows is slow, and then you've got to install your package on it and then run it. And so it was a slow pipeline. They wanted to make it faster.
And they could have done this with containers. They just weren't.
Well, that was the next step that we went to. We were like, well, this is too slow.
Yeah.
Let's look at containers. But containers work best on Linux. And I think at that point in time, there weren't even Windows containers.
Right.
So we were like, okay, we need to run our F# application on Linux. So let's look at Mono. So we tried to run our F# app on Mono. And for some reason that we never managed to figure out, Mono was just incredibly unstable for us. And we still to this day, I don't know why, because if I look out on the wider web, nobody else seems to have these problems, but we couldn't figure it out.
I just don't know how many F# with mono people I've ever heard of.
Well, I feel like there must be some people using it, because I see some other people online using, Mac to do their F# coding. So they must be using mono. But we just had weird problems where the mono runtime would just segfault and just die on us randomly.
Nah, it's not acceptable.
Yeah, and we couldn't debug that, because you don't get a stack trace in your code. You just get a segfault in the runtime. It's like, well,
we're dead.
Yeah,
Start
exactly.
again.
Now, thankfully, the thing that we were writing was basically a data processing batch job.
Right.
So when it crashed, it just restarted and probably worked the next time.
So was it irregular crashing? Like it wouldn't have given set. You couldn't reproduce reliably.
It was completely
worst.
random. It was really bad. It was annoying. So we basically at that point threw up our hands and went, we like this way of deploying things. We like using Docker. We want to find something that will run better on Linux. And at the time, F# and .NET Core weren't a thing yet.
Yeah.
So F# lagged a bit behind on .NET Core.
Still does.
Yeah, it's still a bit behind, but I think it's probably good enough now that you could use it. And if we had it at the time, maybe we would have stayed on F#. But we sort of looked around and we went, okay, what are the things we like about F#? Well, we like all of the pure, functional, immutable. We like all of that stuff. What don't we like? The OO stuff. So we're like, well, why don't we do all these exercises to learn functional programming techniques? We do them in Haskell. Like we had like a lunch group where we were going through the Haskell Programming from First Principles book, which is a really, really good book for learning FP from like the beginning. And that's all in Haskell. So we were like, well, why don't we just try doing this in Haskell instead?
Neat.
Yeah.
From a lunch group to a solution.
Yeah. So like Seek, they have, I think 2 hackathons a year, if I remember correctly. So there was a hackathon coming up and we had 3 days where we could basically just do whatever we wanted. So we're like, well, why don't we try porting the core of our application from F# into Haskell and see whether we can write the business logic? Can we write tests? Can we do a web service call? Can we read some CSV? Can we do a bit of regex?
Right.
And we all of us went off and picked up one of those things and tried to do it. And what we found was that the core of our business logic looked very, very similar in Haskell to what it did in F#, because both languages have a similar-ish syntax. As sort
it's
of
all function calls in the end.
Yeah,
right?
and they're also both ML-ish based, and they've got block indenting and that sort of stuff.
Dan, hold that thought right there while we take a moment for this very important message.
Hi, this is Richard. The Dev Intersection Fall Show this year will be December 3rd to 6th in Las Vegas at the MGM Grand Hotel. The lineup is awesome. Scott Guthrie, Scott Hanselman, Scott Hunter, yes, all the Scotts. But also a ton of great industry speakers for some insight on what's coming up in the world of .NET. Core 3 is bringing client technology like WinForms and WPF into play. Could it be time to migrate your existing desktop apps to this new technology? Come learn more at Dev Intersection, December 3rd to 6th in Las Vegas at the MGM Grand. Go to devintersection.com to register and use the code .NETROCKS to get a discount.
And we're back. .NET Rocks. I'm Carl Franklin. That's Richard Campbell. And that's Dan Chambers. And we're talking about Haskell and functional. And one of the things that is really great about some of these languages is pattern matching. What's the pattern matching like in Haskell? And maybe for those who don't really know what that is, it might be cool to talk about it a little.
So pattern matching, you can think of it like a fancy switch statement. But instead of switching over values like you would in a switch statement, you're switching over structure. So one of the core things generally in a functional programming language is you'll have something called a sum type. And F# people might know it as a discriminated union, where you can say, I have a type and it can be this or this or this. So it's almost like a fancy enum. And so a pattern match basically lets you make a switch between those different structures. But what's special about a pattern match is you can go further. So I can say, if I have a list, I can pattern match into the list. And if the list contains an option, I can pattern match into that. And if the option contains a string, well, I can say it must be this string. So you can pattern match deeply into structures in the one line and then extract the values inside the structures and then use them in the then part of the
kind of like
pattern
a
match.
link might be a similar idea where you can just sort of go in and use operators and try to find
similar-ish to that
values.
Similar to that. It's very, very powerful, and it is something that's sort of intrinsic in Haskell. Pretty much everything that you do is pattern matching in that language. So they've got a number of different ways of actually doing it. So because Haskell kind of has a math root, being from the research industry, it has a math root. You can actually write a function where it almost looks like you're defining the function multiple times, but each time you're defining it, you're pattern matching on something different.
It's almost like a switch. That's your switch statement.
That's your switch statement. Yeah.
You sort of implied there that when you did this 3-day experiment, that the F# code and the Haskell code were very similar.
Yes.
So you're comfortable with F#, you're going to find Haskell just not that big a deal?
You find some parts of it not a big deal. So the part that was very similar was the part of the code that was doing a whole bunch of validation logic.
Okay.
And so we'd done that with in F#, we'd done it with the choice type, and we'd used option. Now, in Haskell, you've got either and you've got maybe. So we basically just switched the types over and used different operators to compose functions. But that function composition is also very similar in Haskell to F#. So that code actually ended up looking quite similar. In fact, because we came from F#, we went and found operators that worked like the F# ones in Haskell and used them in Haskell, which meant the code wasn't really idiomatic Haskell.
Interesting. So you're kind of violating sort of standard Haskell process because you were coming from F#.
Correct. So I think that's something that happens whenever you come from another language.
Always,
you always import some of the stuff. So over time, we went back to that code and like replaced things. So like the simple thing is for people who have seen F# code, there's got this pipeline operator where you basically take some input, you feed it into a function, and then the output of that function you can then feed to the next function, feed to the next one. Similar to maybe in C# how you might have like a fluent syntax. It's sort of how you do it in F#. In Haskell, they've also got that same composition operator, but it works instead of going left to right, it goes right to left.
Oh, interesting.
So you read things right to left in Haskell, and that's sort of I think that's a thing from its math basis.
Yeah. Okay.
Because if you look at how functions are, when you call functions calling functions, if you just write them out with parentheses and then replace the parentheses with dot, the dot is your pipe operator, like from F#, except
sure.
that it's piped to the left rather than to the right.
Pipe to the right.
Yeah, that helps if you write it down. So maybe on an audio podcast.
This probably makes a lot of sense visually, actually.
Yeah.
Not that big.
If only we had a whiteboard.
It's all of a sudden like Arabic, like you're going right to left. But no, okay. I grapple with that idea, but it is interesting to see the similarities. And I don't want to let go of the things that frustrated you on F# again because of the hybridness.
Yeah.
Did you find, and I've heard this before, you just find this, that especially when you're learning the language, you tend to fall back on those old practices. So you would tend to use the object supporting features of F# rather than to get to the more pure functional things.
Look, I think that's both a strength and the weakness of a language. It's a strength in that it makes it much easier to learn. It's much more approachable for people because they can get it wrong and it still works. Right? Whereas
it's just not great.
It's
you hear a lot with F#. It's like, I made this work, but this is not good F#, and now I refactor it and it looks like this.
Correct.
And maybe 3-4 refactories in, you get into more of a pure functional, immutable look, and you're like, this is so different. It does the same thing.
Exactly. So it's an advantage because it lets you go on the journey while still delivering value.
Yeah.
Whereas with Haskell, because it's different and strict.
So it's that bar.
Yeah, the bar is higher for entry, so you have to learn a bunch of stuff up front before you can really be productive in it, which is one of its disadvantages.
Sure.
But, on the flip side, in F#, because you can do the same thing multiple ways and you do have mutability, you can be doing it wrong. And unless you're actively trying to know what the right thing to do is, you could be doing it wrong.
Yeah. Even if you're getting results. Yeah. Do you see much performance benefit when you do it right?
I don't know. I don't have any specific examples of that.
That was never the issue. It's like, hey, we read this in a more functional style, we'll get better performance out of it.
No, I don't think usually. Look, if you're doing it incorrectly, you're probably using mutability.
Right.
So you might be gaining a bit of performance depending upon how you've written it.
Sure.
Because of that, because immutable can be slower sometimes.
There's more memory copying.
Yeah, there's more memory copying.
Right. But in exchange for reliability, and consistency, and there's a lot of strengths to immutability.
Yep. And look, that's one of the places where Haskell, I think, maybe does a better job than F# in that it has its own garbage collector where they expect a lot of garbage values created because everything's immutable.
Yeah.
So they have this concept of a nursery. So when you're writing a Haskell program, because everything's immutable, everything you do is copying.
Yes.
So they basically let the program write into a nursery area, and then they basically look at it and go, well, what's actually still alive, like linked to GC roots out of this? Like, it's just these couple of things and everything else is garbage.
Yeah,
cool. We'll copy that somewhere else and then we'll just delete the entire block.
The whole thing.
We'll just delete the entire block.
And I love that you're talking about this because I've always struggled with this idea that they built a functional language against what was inherently an object-oriented stack.
Right.
IL is fundamentally object-oriented. The CLR was always built on that mindset. And the garbage collector was built on an object mindset that you would tend to have large chunks of memory that would persist for quite a while. You'd have to move things around it. You have the generational shifting approach.
Yeah.
That you would build a very different garbage collector if you knew you were going to be working immutably.
Yeah, which is, I think, where the direction Haskell went.
Mm-hmm.
That's not to say the F#, using F#, the garbage collector is going to bite you all the time.
No,
we never had that experience when we had our F# app. It performed fine. There was no problem with it.
One would argue that the garbage collector .NET is just so sophisticated now. It's been built for so many different ranges of problems. Yeah. It's remarkably tolerant to whatever you throw at it.
Yes.
I think it was when we were interviewing Don Syme, he was taught, he's all old school functional programmer and one of the architects F#.
Mm-hmm.
And he was saying, the reason that we did it is because we have all this code in C# and in VB.NET and in the framework that can benefit from functional programming. So it's not so much as a stepping stone as it is if you have problems that lend themselves to a functional program, you can call those from your C# apps. And this is before, microservices and before any of that stuff.
Sure.
So there really is a value in F# even today of, people who just want to get their feet wet with functional programming and even use it.
It's been 8 years. I mean, F# shipped in 2010.
Yeah.
It's hard to imagine.
Yeah.
You're definitely right, because you can, in F# cut off a piece of your monolith and then write it in F# because it makes more sense and then just call it.
Yeah. It's so simple. Yeah. You're still basically running the same set of assemblies.
Yep.
Yeah.
Well, Richard.
Yeah, buddy.
Guess what time it is now?
It must be that happy time again.
Yeah. It's time to admit that I now know why none of my Haskell jokes are funny.
Why is that?
Yeah, because punchlines are immutable.
Right.
And you write a joke from right to left, but you read it from left to right. So I have to deliver the punchline before the setup.
Wow. That's complicated.
All right. Well, anyway, it's actually time to give away a $200 Amazon gift card. Compliments of Progress Telerik to one lucky member of the .NET Rocks fan club. But first, let me tell you about the most comprehensive developer toolkit for building modern apps on the market today, Telerik DevCraft. With more than 1,100 Telerik.NET and Kendo UI JavaScript components and controls, you can easily build modern, high-performant web, mobile, and desktop apps, as well as chatbots. The toolset also includes reporting solutions, automated testing, and productivity tools, and comes with a range of support options. And new this year is a free online training program for all license holders. With this, alongside thousands of demos with source code, comprehensive docs, and a full assortment of Visual Studio templates, you'll be up and running with the Progress Telerik and Kendo UI tools in no time. Download a free 30-day trial today at telerik.com/download.
Well, all right, buddy. Who's our winner?
Today's winner is Karam Shahzad.
Congratulations, Karam.
Yes. And Karam just won a $200 Amazon gift card, thanks to Progress Telerik, just for being a member of the .NET Rocks fan club. And if you'd like to be a member, go to .NETRocks.com, you answer a few simple questions, and join the fan club. We have thousands of members all over the world. In every show, we like to give away stuff from our sponsors. And every December, we give away a $5,000 technology shopping spree to one lucky member of the .NET Rocks fan club. But you can't win if you don't sign up, so do that now. And we also would like to ask that if you could support this effort to give the $5,000 shopping spree every year by being a Patreon. And you can do that at patreon.netrocks.com. We also like to ask our guest, Dan, if you had $5,000 to spend on technology today, what would you buy?
Oh, so I've got two very old 24-inch monitors for my PC at home, and it's time they needed an upgrade.
Wow.
Yeah, so I think Dell has a very, very expensive, I think it costs like $2,500, 27-inch
he just
monitor.
Hit his buttons.
Oh, yeah?
He's going to talk about his monitor now for
nice.
5 minutes.
No, I want to hear about your monitor. $2,500 for what?
For a 27-inch monitor.
Wow.
I think because it's
4K?
It's 4K, and it supports HDR.
Oh,
so that's kind of why I've been hanging off buying a monitor, because it's like, I don't want to buy a monitor, but it doesn't have HDR, because I play games on my PC.
Okay.
Yeah.
So I want HDR.
My problem with the 27 4Ks is you got to scale them, right? Because it's just the graphics
we're
are
old,
beautiful.
and you'd be like,
you can't read them.
That's true.
I have Dell's 43-inch 4K.
Oh, nice.
It's 120 DPI, man. Like you get to use every pixel of it.
Yeah, and you
it's
don't
definitely
need to
not
use...
HDR though, but and I think they're $1,200 now.
Oh.
So you could buy 3 or 4 of them.
Yeah, that's $5,000.
Believe it or not, I'm still using my Dell 30-inch screens.
The 2560 by 1600.
Yeah, that I bought in 2007.
Yeah, wow. Is that long ago?
Still running.
Yeah. Because I got one of the Apple 30 inches when they first came out. And that was 2006.
Yeah.
So, and then they did start making more of them. And that was back when it was literally like, it's Apple, right? So they know exactly how long your video card cable should be. And so it was literally a hardwired cable, and I had to put a shield around it to put an extension on it. It was dual DVI.
Yeah, dual DVI.
That's saved me.
Yeah.
That's what I have.
Give me DisplayPort. DisplayPort is your friend.
Yeah, my monitors are so old that they only have DVI. They don't have HDMI or any of that. So it's time for an upgrade.
I'll tell you, and it's something you use every day.
Yeah.
Like, I am a big believer in the things that I got to deal with every day, make them extraordinary. Great Wi-Fi, a great keyboard, a great mouse, great displays.
Yeah, totally.
They have a huge impact.
And a great propane range. In my case.
It's true.
Yeah,
you have a very nice range.
I do.
I've seen your
2
range.
of them.
Yeah, they're good.
Nice.
You know what I'm laughing about? We are halfway through the show, and we have not talked about the Haskell dev environment at all. And I kind of did this intentionally. It's because it's easy to find excuses to not do something, which is like, oh, that's too different from the way I've lived before. And it's certainly for someone coming from the studio world where F# is super convenient and so forth.
Plus Intellisense and all the bells and whistles you get. Yeah.
Let's work down the tool chain. What does working Haskell like? Do you use VS Code?
You can, yes. Okay. So unfortunately, the Haskell tool chain is not as anywhere close to as good as F# or .NET.
Okay.
Right? It's just not.
That's just sort of reality.
It's just a reality. And the community is working on improving it. So it's definitely got better over the last couple of years since I've used it.
Okay.
But yeah, there are still rough edges on it. So
sure. Is there really only one flavor of Haskell? Like, is there tend to be a...
That's a good question.
Yeah. Because C++, like, which flavor would you like? Everybody makes one.
Yeah. So I think in the past there were many different Haskell compilers, but I think most people now use the Glasgow Haskell compiler.
Glasgow one.
Yeah, otherwise known as GHC.
Okay.
Because that seems to be where everybody has put their effort in. So all the new language features and stuff generally end up in GHC. So yeah, you basically get GHC, the compiler, and I think they're on a 6-monthly update cycle now, so it comes out fairly often.
And it's open source, so you can participate. If you really need a language feature and you feel like you're up to it, you can be part of that process. Not easy.
No, definitely not easy. Working on language
is hard.
Definitely not easy, particularly in the Haskell compiler.
Isn't there an Intellisense way to do that in Visual Studio Code with languages? Just a way to develop it?
Yeah, there's been third-party Intellisense extensions made for VS Code a lot, so that's why I asked. It's like, if there's any chance for Intellisense in Haskell, which I almost don't know if that even makes sense.
It does. So VS Code's got the language server protocol, and there is a Haskell implementation. So there's a backend. There is a backend for Haskell, but you're right. Intellisense doesn't work the same way as it does because there's no dot. You can't go dot and see what's next.
Statement completion kind of thing. Yeah.
So generally, that workflow in Haskell would be you putting an underscore in the code, and then that will be an error from the Haskell compiler. And the Haskell compiler will say, you put an underscore here, but I need and then it will tell you the type of what it expects to see there.
Interesting.
Yeah.
So use the compiler errors as a way to be more productive.
As Intellisense.
Yeah.
Why not?
It doesn't sound... It's not as bad as it sounds because you can take that type that it expects and you can go to a search engine called Google, which is part of the Haskell ecosystem, and you can put the type signature in and go, find me a function that does this. And it will search all the libraries that are uploaded.
So Haskell developers copy and paste off of Stack Overflow just as much as C# developers.
Yeah, we copy off of Google.
Off of Google.
Yeah.
Google.
Yeah.
Google.
I love it.
So, the tooling is there. Like, you can go control space and get a list of functions. So you can start typing the name of a function. It will find it. When you're importing modules, you can go data dot and it will complete the other ones for you. You get underlines. So you get squigglies where errors are and warnings. And you've got your little language expansions to go, a couple of letters and press tab and it fills out what you were. So that sort of stuff is there, but it's definitely, I think renaming is there in the newer version of the tools as well. So I think you can rename now as well. But
one of the things
it's not ReSharper.
One of the things that Don Syme was very, very happy about and proud of was the type provider features of F#. Is there anything like that in Haskell?
Not quite the same, but there's something called template Haskell, which is one of the language extensions you can turn on. And the template Haskell lets you, at compile time, generate types and Haskell code. Okay. So I want to say maybe you could use that to do something. You could use that to do something type provider-ish.
Right.
But it's not quite the same thing.
Yeah.
It's a little bit different.
Right.
Like, for
Plus,
example...
types aren't really objects, are they? So there isn't a this dot, that dot, whatever.
No, but saying that, it's not that different, right? So you do have record types that have properties on them, and they are nested, so you have an object graph. So if you can imagine a JSON document, right, you can still express that as types. So you might not dot through it, but you will read through it. And it's just the syntax is different in doing that.
So editor makes a bunch of files. Yep. Now you're running a script to a compiler.
So there's two different ways. There's two different, compiling stacks for Haskell. There's Cabal, which is like a build tool and package manager for Haskell, and then there's Stack, which is takes a different approach to managing packages and dependencies and doing compilation. Cabal is it's the original version, and then Stack sort of came in later as competition because Cabal didn't have some features that the people who wrote Stack wanted.
Right.
So
as it happens in the open source world,
yes.
right? If they get frustrated enough, make a competitor.
And it's been good, I think, because Cabal now has some of those features.
Right.
So
they pushed each other.
It's a bit like sort of Yarn and NPM.
Yep,
NPM had issues, so they made Yarn. It's like, well, we're going to fix these issues over here, and now NPM has those features. It's a little bit like that.
Yeah.
So Stack, I personally use Stack because I think it makes developing really easy, because what they do is they basically they have most of the Haskell, well, a lot of the Haskell packages in what they call an LTS, where they basically every night they try to build the latest version of all those packages together and validate that they all work properly. Then they issue an LTS where they say this is all of the packages with version numbers pinned. So I just say I want LTS 12.11 or something, and I don't have to think about I need this version and that version. They've already done the dependency solving for me. And then I just take that and I say, I want this package, that package. I don't worry about the version, and it all just works. And it works on Windows, and it works on Mac, and it works on Linux. And I don't have to think about it. Because I remember before Stack, compiling on Windows kind of sucked.
Sure.
Like I remember trying Haskell years ago before I did it at Seek, before Stack, and trying to make stuff compile on Windows was quite painful. I couldn't get it to work. But with Stack, it just works.
Being nostalgic here, I seem to remember. You remember when .NET first came out, and their big announcement, of course, was web services, but a big feature of Visual Studio was about 20 or so languages that it supported.
22,
yeah. And I do remember Haskell being one of them.
Yes.
So
it went away. It just didn't get supported.
Yeah.
So, and of course, I'm working, I don't know if you know this, Daniel, but lots of people do. I'm working on a book on the history of .NET.
Yep.
And so I have talked to the folks that were leading the team around the initial deployment. And there was an initiative to get languages from industry and languages from academia.
Yeah.
And most of those academic languages only went through one version.
Yeah.
And so the OCamls and the Haskells, they were all in that category.
COBOL lived.
Yeah, but COBOL wasn't run by Fujitsu. And so Fujitsu made business around that. And they still do to this day. I mean, and Fortran's still alive for the same reason. IBM continues to support a flavor of Fortran.net that you can get off the marketplace because it's business. But academics, it's a different set of rules. I mean, what do you bet that was done by grad students as a project that they got marked on and then they moved on?
Yeah.
So, I mean, I'm sure the code is somewhere. Goodness knows what state it's in.
Yeah, right.
And it was an interesting ploy or idea. This, they were trying to counter Java, which was one language every platform. And here they're like, one platform, Windows,
all the languages,
but any language,
right?
It was an interesting idea. Just, I don't know that it amounted to much.
No.
And again, you still deal with this issue. It's all going through the same intermediate language. It's all going through the same runtime. And that runtime is opinionatedly object oriented.
Yes.
You are doing convulsions under the hood to stay functional in an object oriented realm.
Yep.
Like, I am still hooked on this idea that what if we had, a functional runtime that worked differently in the operating system? I don't know that's essential. Like, these are not problems I think too much about anymore, just because we have so much compute. We don't have to be that efficient.
But let's talk about performance. That's something we really haven't talked about. I imagine being so bare to the metal and being functional, it's just absolutely blazing fast.
Yeah, it can be. Again, it depends on how you write the code. Some things are faster than others, but Haskell's can be extremely, extremely fast. There's always a trade-off being a garbage collected language on how much.
Well, you just don't know what the performance is going to be.
Yeah.
Right? Like, you don't know when it's going to hit.
And look, in Haskell, that can sometimes be a challenge because Haskell's a lazily evaluated language, which basically means you write the code in a certain way and it doesn't execute in the order that you write it. It executes when things are required. So you can kind of think of it like every single expression has a thunk around it. Like, you have to pass nothing to it, like a unit to it, before it will actually run. So everything is lazy. So sometimes reasoning about performance and memory is harder in Haskell, but at the same time, sometimes it's a lot easier. So things that you write that would otherwise be inefficient in F#, for example, are not in Haskell. They just work.
Have you seen Haskell's influence in other platforms and languages? Because it has been around so long, do you see any of the concepts that started in Haskell making their way into other platforms and languages?
I think so. So if you look in the JavaScript ecosystem, you've got Elm and you've got PureScript.
Yeah.
Elm is very Haskell-ish, but what they've done is they've sort of stripped out all of the advanced features and they've gone, we're going to make an extremely simple language that's very easy for people to pick up because we haven't got all the fancy stuff. We're going to keep it that way. So they've got that's their opinion on it. Whereas PureScript sort of went the other way. They were like, well, what if we had a Haskell level language with all the fancy type features and it compiled to JavaScript and it had provided all that purity and safety and type classes and higher kind of types, and we had all of that magic and we put it and compiled it to JavaScript, what would that look like? So I think both of those languages probably got a lot of influence from Haskell.
That's really interesting. I don't think we've talked about debugging Haskell, or you just simply do not make bugs in Haskell because it's that awesome. This doesn't happen.
Don't joke. If it compiles in Haskell, it often just works.
Yeah, no, I can buy that. Immutable, pure function.
Yeah.
Can the compiler detect circular references and functions that call themselves over and over again and never exit?
No, those will still crash.
So if you're really stupid, you can shoot yourself in the foot.
You have to be pretty clever to get a really infinite loop that will take a machine down. Like that doesn't just happen. You have to work at it.
I suppose.
You can definitely make it crash. And unfortunately, because Haskell, one of the downsides of it being such an old language is that there are what are considered to be not good things still around in the old libraries.
It's baggage from the earlier versions.
So it's a bit like the array types and the old ungeneric types in .NET. You wouldn't use them
you're not
anymore.
even going evil. It's like p-invoke.
Yeah.
Right? It's still there. It's just a really bad idea.
Sometimes that's all you have.
Yeah.
Very few.
There's some of that stuff still in Haskell. Like there are functions that will crash if you call them under certain circumstances.
Interesting.
So for example, if I index into a list and that list isn't long enough for the index, if you should be using a function in Haskell that returns a maybe. So maybe you get a value or you don't you give it an index that's too long for the list.
Right.
But there is a version of that function that will throw an exception.
Okay.
And so that's called a partial function, and you don't want to use them.
Well, we still have constructs like stacks. Obviously, if you have functions calling functions, there's a stack so that we can back out of it, right? Is there a finite amount of stack space?
There is, but it kind of works differently in Haskell. Because of the way the language runs, and I'm hesitant to try and go into the detail here because I'm not fully versed in it and I'll probably butcher the explanation, but there's a lot more tail calling going on in Haskell, and so it unwinds that stack. And so you might be doing something that on a language like F# you might blow the stack, or maybe not, because F# does actually do tail calls. In Haskell you just won't. It will just keep going and it will just work. Yeah. So there is a stack and you can blow it, but if you
eventually run out of memory.
Yeah.
Right. And we're not talking about all memory, but whatever the operating system is allocated to that execution space. Like if you behave badly enough, you're going to pop it.
Yeah.
And the OS is probably just going to kill you. Like, it's like, boop, you're done.
But you don't have absolute addressing. In other words, there is you're shielded from memory. In other words, like in C++, you can, and I'm not telling. In C++, you can write over the end of variable space and just out into whatever.
No, you definitely can't do that in Haskell. Haskell's a very high-level language, so all of that stuff is abstracted from it.
And it's running in a virtual machine that does its garbage collecting and so forth. So it's the thing that has the relationship with the operating system ultimately.
I don't know whether I'd call it a virtual machine because it doesn't compile to some IL and then be jittered.
Right.
It compiles all the way down to native.
Runtime.
But
it's the runtime.
But there's definitely a runtime in there that does the garbage collection.
That's a better explanation. I appreciate that. Yeah. But it happens to be a runtime that does garbage collection.
Correct. Yeah.
Yeah, very cool.
I'm really excited about this. This is
pretty cool.
Really, really neat. And it's nice to see a role. I mean, isn't it great now that we're at sort of an architectural time where we have these principles like web service calls that just allow us to have a totally different environment, totally different language, but we speak a protocol that we can live with.
Yes.
And you don't need to know one way or the other. I mean, one of the original promises of .NET going back to 2002 was finally you're going to be able to program in more than one language and have them interoperate.
Yeah.
And I think we've sort of gone past that now with these larger constructs. It's just not that big a deal to work in multiple languages.
No, and I think that's a good thing because it lets people pick the right tool for the job.
I totally agree. Absolutely.
So what's next for you, Dan? Where are you off to after NDC Sydney?
back to work. So
New job.
Yeah, new job, back to Melbourne.
I'm impressed. New job, got a week off to be at a conference. Well, not off like you're doing.
Yeah. They were accommodating. I'd tell them about it up front before I joined.
That's smart.
They've been very accommodating.
Any of your peers here as well?
Sorry?
Any of your peers from the new company?
No. Liberty, they sponsored another conference in Melbourne that was just this past weekend, and there were a whole bunch of Liberty guys and girls there. Yeah, I went to that.
Oh, so you're conferencing.
Yeah, that's right. So it's been like a whole conference week for me.
I love this job. I didn't really work.
Yeah. So that was on a Saturday. So,
Oh, okay. You took your weekend.
Yeah,
off.
It was on the weekend.
That's
but
something.
they supported that conference and they sent a whole bunch of people there and it was good. But no,
awesome.
they're not up at NDC Sydney. Maybe I'll get them to come next year.
Next year.
Well, we have a few minutes left. Maybe we'd like to take some questions from the audience and just repeat the question because we can't hear them. Does anybody have a question for Dan Chambers? Anyone?
Sure.
Sir.
The question was, what sort of resources can you look at to learn Haskell? I think the best one would be Haskell Programming for First Principles, and it's a textbook, haskellbook.com. It's a really, really good book, but it is a very long book. It's a big book, and I think the reason why that book is better than the other ones you can find online is that it starts from the beginning. So it literally starts at lambda calculus. And that sounds scary, but I guarantee you it's not. They basically explain where functions came from, and that's from lambda calculus, and it's not complicated. And they explain everything. And that learning curve, people make a joke like the Haskell learning curve is like a very steep cliff. Well, the Haskell book flattens it. So it's a long curve, but it's flat. Well, flattish. So they take you step by step through every single concept you need and they build on it. And they also put exercises in there because I think one of the things about functional programming is that sometimes it takes a bit before it clicks.
Yeah, right. You have to do it a couple of times.
Yeah, exactly. And so to have the exercises there really gives you some direction on how to make it click because it's one thing just to read something, but it's another thing to do it for yourself. And the exercises give you a bit of structure to do that.
As part of this just grappling with functional programming period that you have to think, especially if you have experience in object-oriented programming, you have to think through the problem differently.
Yes, absolutely. You can't, particularly in Haskell, you can't reach for some of the tools you might have had in the past. So for like for loops, not a thing.
Not a thing.
Yeah.
It doesn't exist. Doesn't matter. Why would you do that?
Exactly. You have to become more familiar with recursion. And then after a while you realize, well, that's just a fold and therefore I don't need to write that anymore. I can just use a fold instead. So over time you build up these abstractions, just like we do in imperative languages. We just don't kind of realize we've done it because we've done it over the years.
Yeah,
like if you think about the progression in imperative and structured programming, when we went from while loops with gotos, and then we started writing for loops where we had for I equals 0,
bounded for loops.
And then we went for each, and that is an abstraction over IEnumerable. Like it's the same thing. Like we build up these abstractions, except they're just different abstractions in something like Haskell.
That's cool.
You guys know what the dictionary definition of recursion is, right? C recursion. You had a question.
So the question was, if I could bring something from Haskell into F#, what would it be? I'm going to say it would have to be higher kinded types, because that's something that .NET I think holds F# back from, is because .NET generics don't support something called a higher kinded type.
What's a high kinded type?
So if you think about, say, list of T, right?
Okay.
The kind of list of T is really a type function that when you give it a type, it gives you back a new type. So list of T takes T, and when you call list of T with T, you get back, a new list that's specialized to that. So if I have
customer, whatever.
Yeah, so if I make a list of customer, I've now got a new type that's list specialized to customer. And if you look under the covers at what .NET really does, it does actually specialize. If you put a value type in there, you'll get a different IL representation, and it'll compile it differently. So it does do the specialization. So higher kinded types is where you can write code that's abstract over the higher kinded type. So I can say, I want a function that will work for any type that will take something else. So instead of saying I have a function that takes a list of T, I can say I have a function that takes an F of int.
Right.
You can't write that in .NET. And why that's really useful is there are these concepts called functors, which is basically, think of select. It's basically the concept of select. So anything that is selectable, if you like, that's a functor with some rules behind the scenes, some rules as how that select should sensibly behave. And I can say, I can write a function that works for anything that is selectable, if you like, where the high kind of type is that thing. So it would be, I could use it with lists, I could use it with maybe, I could use it with IO or task. Task, you can think of as something that could be selectable because a task contains a value and I might want to change that, convert that value from one thing to another. So I can write abstractions, I can write functions that work over these abstractions, and I can't do that in F#. And which is a shame. I'd love to be able to do that, because right now, if I want to do a map or a select, I have to go list.map or array.map or option.map.
And it's interesting to realize, hey, we've always thought about the generics implementation in .NET as being the really robust one, because we were comparing it to what Java did.
Yeah.
Right.
And you've just described was clearly a superior model of a type system with all of that potential, and thinking, wow, maybe .NET can't do that.
I think Bootsy Collins was first. He was the original Functor. Yeah. So we got to give him credit.
Okay.
All right. Well, anyway, we're out of time. Dan Chambers, give it up for Dan. Thanks.
Thank you.
All right. We'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1. Recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC. Yes, I'm a toy boy. Life is hard.